Okay, well, I had all the fun of helping develop these qualifications, and now I've got all the fun of telling you why it was I'd helped to develop them the way they turned out. Now, as Eddie's already mentioned, there are two qualifications. They have a common paper, the Introduction to Quantitative Reasoning, and then there's a second paper that's different in each of the qualifications. Why did we do that? Well, although we don't yet know whether these count as core maths qualifications, that's very much what we had in mind when we developed them. We had in mind the students who could do with doing some more maths, aren't doing A-level. What's the right things for them? And we read various things, which I'll be telling you about in the next few minutes. One of them was the expert panel report on core maths, and it outlined various groups of students for whom these qualifications should be suitable. And as we sat thinking about what sort of maths does somebody going on to a degree in geography need, what does somebody who's thinking of a career in construction need, what does a future primary school teacher need, and all these various other groups of people, we realised that they didn't quite need the same maths. They all needed some more maths, but they didn't need quite the same. And so then we started to think about perhaps we need more than one qualification to meet their needs. They need to be able to be good at the stuff they learnt at GCSE, or at least the stuff they learnt at GCSE that's going to be useful to them, which is maybe not all of it. There are students who need to do more algebra and they need to learn calculus, and that's who AS and A-level are for. There's no sense in inventing another qualification when we've already got AS and A-level, so there's not really a lot of algebra or calculus in these qualifications. There's sort of bits skating around the edges where we thought they were relevant. And then we started to think, well, what do the others need to know that they haven't already done at GCSE? So we were influenced by quite a number of things. The all-party parliamentary group on financial education, we got involved with them. And when they brought their report out, we'd written a section on what financial education at Key Stage 3 and 4 should look like, which we'd based on the PISA report on financial literacy. And we'd also thought a bit about how that looks post-16 as well. It didn't make it into the report because this was a pre-16 report. This is part of the stuff we put in the report. And as we looked at these things when we were developing our core maths qualifications, I thought, well, they haven't put all of this into GCSE higher tier, but this is the sort of stuff that would be useful for students to know. It is useful for them to understand compound interest and how it works, so that when they see the adverts for loans or savings or whatever, it means something to them apart from, is this number bigger than that? It's useful for them to use a spreadsheet. The students that I meet that I taught that are not actually using maths perhaps in the way that we'd understand it from the textbooks, what they say to me that they do is they use a spreadsheet, and they ought to be able to learn how to use that, particularly for financial calculations. And hopefully they'll all get to go abroad on holiday sometime, so they ought to understand how foreign exchange works. We worked on a project funded by the Cloth Workers Foundation called Integrating Mathematical Problem Solving, and that was looking at what sort of maths is there that supports other level 3 qualifications. Particularly we looked at A-level, and we also started thinking about other vocational qualifications, and that got difficult because there's such a lot of vocational qualifications and they're all different, and we couldn't quite pin down all the maths that they needed, some of which we realised was very, very specific to particular areas, and some of which was perhaps more general. We came up with an outline curriculum that we put in the report, things like finance, estimation, working with large and small numbers. That was informed by the maths in other A-levels, but it was also informed by mathematical needs for employment. Things like estimation, a lot of employers were saying if only they could estimate, if only they were good with money, all that kind of thing, if only they understood risk. So those all made it into there. We looked at what other people were doing in this area. Timothy Gowers had a blog that included still does, included an entry about how should maths be taught to non-mathematicians. And we were very fortunate in receiving funding from the DFE to develop those ideas into a curriculum, and Terry's going to tell you more about that in a bit. The key influencing factor was that the starting point isn't here's some maths, now what can we do with it, but here's a problem to be solved, now what's the maths that's needed? And that's the way that people by and large think in the real world, that maybe don't even think of themselves as mathematicians, or maybe didn't like maths at school. They think, well, I've got this problem to be solved, now how can I go about it? Roger's going to speak a little later about the work he did producing this report for the RSS and the actuarial profession. I was fortunate enough to be assistant researcher. Well, that influenced our development as well. And we thought a lot about vocational students and people going straight into work after the age of 18 and what's suitable for them. One of the things we read was this book, which is written by a variety of authors from different countries. And one of the questions that they were asking is, are there actual workplace applications of the sort of maths that people learn at school? Or is that just a thing that teachers like to think happens, but it doesn't really? They made a distinction between the sorts of questions that come up on tests and the sorts of problems that people actually want to solve in the workplace. I expect you'll be able to tell which is which. As we looked at the sort of questions that people really want to solve in the workplace, we thought, well, that's the sort of thing that we're starting to think about with critical maths. So at one point we thought, do we need a third qualification that's going to suit vocational students? And we came to the conclusion that actually, no, we don't, because a lot of the things they need are in there already. Lynn Steen was one of the authors of this book about mathematics in the workplace. So I started looking for other things he'd written, and there was a United States document called Mathematics and Democracy that was making the argument that if people can't think in a numerical sort of way, they cannot fully participate as citizens, and that's a problem for democracy, because it's the citizens in a democracy who decide how we're governed and who does the governing. And if they haven't got the skills to be able to think in a numerical way, they can't do that. This is a quote that sort of very much influenced me, bringing to the fore that in this world we live in, you see quantitative information everywhere. You see it in the news, in advertising, in reports. You see it in sports, you see it in the workplace and in education. And not only was that thinking an influence, but that's where the word quantitative comes from. And I've learned to say it now, and I've even sometimes learnt to spell it. But that was a sort of big thing in a lot of the thinking that was going on in the United States, and has also started happening over here through things like the Q-STEP programme in universities. So anyway, who are they for? Whoops. That's what's in quantitative reasoning. It strengthens and develops what they understand from GCSE. There are spreadsheets, problems in realistic contexts, and we're encouraging critical thinking about quantitative information, and I'll tell you more about that later after you've had a break. Now, in my opinion, if all the future journalists and politicians did this qualification, the world would be improved. Now, not all of your students are going to become journalists and politicians, but they will all be reading and listening to the stuff that these people produce. So it's, in my opinion, useful for everybody. The quantitative problem solving, you'll see that there's a lot of similarity. The difference is it focuses on a much wider range of statistical techniques, including hypothesis testing, and the kind of person we had in mind was somebody who's going to go on to perhaps geography or psychology at university. And again, that's not everybody, but everybody will be subjected to statistical information, and if they have a better understanding of it, that's good. Not only do they have the first paper in common, there's also common content between the second component. When Roger and I were working on these, we were sort of looking at each other's work, and in the end we got to the stage when neither of us could remember who'd written which particular phrase that the other had borrowed. So there's more than 50% common content. You can, if you want, teach the introduction to quantitative reasoning in year 1 to everybody, and then students go onto either route in year 2. That's fine. If you want to teach pick one qualification, teach the whole thing as an integrated 2-year course, that's fine. It's up to you how you do it. There are a variety of ways that you can go about it. In particular, we had in mind the students who might stop after 1 year. That was something that people in sixth form colleges and in FE said to us, well, what if they don't only do 1 year? We do have the introduction to quantitative methods still accredited as a qualification, and it's very mostly the same content as the introduction to quantitative reasoning, although I'll tell you what the differences are later. So it would be possible for them to do 1 year working towards the introduction to quantitative reasoning and then take the introduction to quantitative methods exam at the end of that year. It's not a core maths qualification, it's not big enough, but it would still be a recognised qualification that they could come out with. Is there a textbook, people have asked? Well, no, we haven't had time to write and publish a textbook as well as everything else, but also because we want to bring in genuine problem solving in a variety of contexts, it has actually proved easier to put resources online. So with a growing set of resources online, full resources for the introduction to quantitative reasoning and for critical maths, we're working on the statistical problem solving resources, and the first ones will be uploaded hopefully by the end of next week. We can also respond to your requests. So if people say, well, why haven't you written a resource for so-and-so thing? Well, we can. Fortunately, OCR have kindly provided us with funding, which means those resources are free for centres to use. They're in a VLE, and you won't be able to see any of the writing on that, but it will hopefully pique your curiosity so that you go and have a look online. There's a free sample that you don't even need to register for, and if you register, you get access to the whole lot. Here's an example that I've made the text big enough to read. It's in the financial problem solving section, and it's based on students trying to decide whether it would be possible for them to live in a place of their own if they left school and were earning the minimum wage, which some of them will. And they might well think, oh, it'd be great if I had a place of my own. I wrote that because I thought, well, it's the sort of thing they ought to be thinking about. And actually, it's not straightforward to get to an answer. There's a lot of thinking. They'll have to find out information. Sometimes we get feedback on our resources, particularly with them being online, and sometimes the feedback is there's a mistake in the answer to 5B, so we correct it. And then we got some feedback on that particular resource that said that was one of our best lessons and students learnt a lot, so I'm proud of that.